Fix the fuse on your guitar amplifier. Troubleshoot your Marshall Valvestate 2000 AVT power supply. This article was written to answer the specific question of a guitar enthusiast, quoted below. Hi Wayne, problem with my Marshall Valvestate 2000 AVT. Every time power is applied, fused instantly burns out. Replaced fused several times with correct ratings and still get the same results. Is it something internal that's causing the problem? What can I do to start to diagnose? The fact that the power supply fuse blows instantly indicates a short circuit in the power supply unit. Please ensure that the power is switched off and the amp is isolated from the mains. Additional precaution can be taken to drain the power capacitors, those big bulky colored cans, using a 3.3 k ohm resistor. Identify the power supply stage, characterized by a bulky transformer, coil, and a bridge rectifier. You can't miss this stage as they have bulky capacitors to smooth the DC to the other stages. Ensure that this is not an SMPS, used on some variants. An SMPS can be distinguished from a normal transformer rectifier-based power supply by the sheer difference in size and weight, together with the fact that it is enclosed in an aluminum chassis of its own. SMPS are small and light. Classic transformer power supplies are big, heavy, and exposed. If it is an SMPS-based unit, simply replace the SMPS. Check the wiring before the transformer stage for shorts. The first test would be to isolate the primary coil winding of the transformer. This is the coil whose two ends are interfaced to the raw mains power through the fuse and power switch. Using the multimeter, test continuity of the mains power cord to the stage via the switch and fuse. We are checking for a short circuit, hence a 0 ohm continuity will indicate that you have a short in the pre-transformer stage. If this is the case, test the continuity on the mains cord and the internal wiring. If a short is identified, replace that component, mains cord, fuse holder, internal wiring, etc. Check the transformer for shorts. If the pre-transformer stage is clear, test the continuity of the primary coil, transformer, with the multimeter kept on its most sensitive settings for resistance and continuity tests. If you get a resistance above 30 ohms, it suggests but does not confirm an OK on primary coil. If the primary coil provides a resistance of less than 30 ohms, remove the transformer and isolate it. A short in the coil can actually be smelled, as the burnt enamel causes a distinct smell. Thereafter, You can connect it using a fuse in series to a rheostat, gradually raising the input voltage to primary while testing the output AC voltage in the secondary. If there is no marginal increase in secondary AC power, you will have to replace/rewind your transformer. Caution: if you do not have a rheostat, please take caution and do not test it directly to the mains. It is better to have the transformer replaced or rewound. If your transformer is okay, the next stage we're looking for is a shorted bridge or capacitor, as this may at times cause an overload on the primary stage and the blowing of the fuse. Check the bridge rectifier for a faulty diode. Assuming you have cleared all the above stages, the next stage to test is the bridge rectifier. Remove the capacitors and isolate the bridge rectifier. Test the individual diodes. Diode tests can be performed by multimeter continuity tests. The characteristic of the diode allows continuity in one direction and inhibits it in the reverse direction. The individual diode being tested will have to be isolated by desoldering and isolating any one of its ends. There are 4 diodes that require to be tested. The diodes, if found faulty, will have to be replaced. Check for a leaky capacitor. The last component to be tested in this stage is the power capacitor. Usually these components can be visually assessed for leaks and blow-offs. They also emanate a burnt stench when they blow off. Their blow-offs are dramatic events and are mostly heard like a firecracker. Testing them with a multimeter is quite trivial. As you connect the leads for a continuity test, you notice an impulse indication of resistance, which is actually the capacitor charging up from the multimeter's power source. In most cases you identify the fault in the third step, and it's usually to do with a burnt coil in the transformer or a short in the wiring after the fuse stage. However, please take due precautions, as both the primary and secondary stages deal with voltages in excess of 100 V and are capable of driving high current amperages. If you face any more challenges with respect to the same, please feel free to comment or contact. Required tools: you will require a multimeter, a tester, power line, a soldering stick and some lead to proceed. Caution: please ensure that the power is switched off and the amp is isolated from the mains. Guitar power amps are designed to operate in DC voltages in excess of 80 V and have a high power handling capacity capable of delivering 10 amps of current to drive speakers. If you do not have a rheostat, please take caution and do not test it directly to the mains. It is better to have the transformer replaced or rewound. Additional precaution can be taken to drain the power capacitors. those big bulky colored cans, using a 3.3 ohm resistor. Quicktips: use all your senses, smell for any burnouts. Transformer burnouts: smell of burnt enamel and capacitor blow off smell acrid.